No.
Okay, so here's your rules. Noel, make sure you have this written down. All right, number 12 on your blue sheet. Okay. She can pause it and go back and copy stuff. Okay. All right, so we're going to find the derivative here. Notice the x, like it was when you guys did regular derivatives, the x isn't the base. Like you guys are used to doing like x cubed or x squared, something where you guys had like numbers up in the top. But if the base is something other than e or other than an x, or x is up in the top part, we're going to be using number 12, all right, that a to the u. So it might be helpful for you guys to kind of take this in steps, right? Figure out what the a is, figure out what the u is, and you do each part, and then you plug it into your formula. So the a here is acting like the constant, like the base. So a would be 3, yep. What's the u going to be, you think? 2x, great. The du is going to equal 2, yep. How's that part so far? Good, okay. Now, so when you guys are subbing things in here, all right, the du dx is a little bit easier. How did you guys get du over dx? Good. Right. So actually, it doesn't really matter. I guess now that I think about it. So if you guys are looking at this part, right, your du over dx is really the same thing. Like your blue sheet uses a u prime, the book uses du over dx. Why does that make sense? Okay. So it's just up to you guys, like which one you're reading off of. They mean the same thing. We can use what du over dx equals, which is 2. Or if you think what u prime would be, it would just be 2. So it's the same exact idea, just depending on what you're actually using. Now, when we sub everything back in, we're going to be using this formula. So the derivative here is going to be ln of 3 times 3 to the 2x times 2. Yep.
So that is your, when you put it all together, can you put
yeah, we want to like simplify some of this stuff for sure. Okay. So we can't do 6 because they're not like things. But you could do 2 out in front and then ln of 3. Now your book does some weird stuff in here with the exponents. So if you guys had 3 to the 2x, what they did was they made 3 to this part right here. They evaluated that and then put the x on it. So, like, what is 3 squared?
8 or 9.
9. So they made this as like 9x. I thought that was kind of like odd. Yeah.
And how come like you can't, because that's like the thing itself. Well, if you like the property, it would be kind of like.
Let me try to think.
Like 3 to the 10x.
Because 3 squared times
300 squared is different than
3x
to the 20.
Isn't that 9 times 3x?
Times 3x. Yeah. Because that would be the property.
But it's the actual number you would do that.
You would do that.
Right. The reason you're
Like
missing
if it was 3
3
to the 2 times 3.
right? You're missing 3 that way. Let me just double check something real quick. You know what I'm missing? You're missing the 3.
Are we going to? We have 4 left. 5.
Sorry, let me just look real quick. I just don't want to mess you guys up with this part. Right, because it seems like you have a 3x left.
Because like Tom said, 3 to the third or 3 to the 6 is different than 9 to whatever x would be.
Yep, they do it. They do it. No, they just do this hard. It's the same thing. Where's the extra 3 though?
Because like say if it's like 3, say if x is like 4, so it'd be 3 to the 8. But then if you do 9 to the 4, you should get the same answer. So it doesn't matter.
Oh.
Calculate it on.
Or
There we go.
Or
It works.
Okay. No, okay. So Carolyn, Carolyn used a number to kind of like check
I
this.
just use the number.
So if you did, okay, 3 to the 2 times 4, is that what you did?
Yeah.
Okay.
And I got 6,
3 to the 2 times 4. And then, okay, so if you made this, and you actually did 9 to the 4.
Yeah,
That
we're
can
not,
be the same
we're
thing.
not gonna be there Friday. We played Granville on Wednesday, and we beat them by like a lot last time. Sorry for interrupting.
That's alright, stop it right now.
Granville. Who's Granville?
The team that sucked at everything.
I'm the team that beat us 3-1
What's the problem?
Okay, so Carolyn just said that these two things are the same. Like if you did 3 squared, like you made it 9, and you kept it like this, or you made it like this, it comes out to the same answer. So we were saying like, well, does that really work? It does. She just put a chord and tested out with F. So if like you did
No, it didn't work.
3 to the 8,
Oh, no, I didn't do it right. Right.
or you did 9 to the 4, see how it's the same thing? Okay. So actually, if you guys did leave it like this,
She's right.
it would be fine. But the book just takes it to like a next level. They just do this part.
I still don't understand why that's a problem. Why
we got them forced.
Oh, because people didn't like get why these were the same. So we just don't overthink it. Okay.
That's what I figured.
Alright, softball people, talk about what you guys need to do after.
I'm good, sorry.
Okay.
Alright, next example.
Alright, let's do another one. Here's your second one. Alright. So same thing here. Figure out what your A is, figure out what the U is. Alright, what do you guys think your A is? 7, good. The U is going to be perfect. What do you guys think about the DU?
2
Good. 2dx, perfect. If you want to divide by dx now, or you could just think what's the derivative of u. Either way, doesn't matter. Okay. So now let's plug everything in. Use your formula for some help. Alright, if you guys need to, like take out that blue sheet, make sure you're using this. So we're going to take the ln of a, so the ln of 7 times 7 to the u, or 7 to the 2x minus 1, times 2. Yep.
So did they do the same thing?
No, because of the subtraction. If it was like multiplication, they would have, but this would mean something different, right? So, you guys can like rewrite this if you want. Usually we bring the constant to the front with 2 ln 7, then 7 to the 2x minus 1. Okay. I mean, you could put parentheses around some part, but that's it.
Couldn't you still do it if you took 2 out of the x minus 1?
No,
You can't because it's not a GCF. If it was
Yeah, but
like,
it would be 1/2. The x minus 1/2.
yeah, but why would you make fractions? You don't need them.
I'm just saying.
How come you moved the 2 out but not the first 7? Like, how come you moved that 2 out?
You're
Well,
taking the
to the
LN
outside.
I mean, yeah, this could be the same thing if you did ln 7, like 2,
Okay, so I didn't know if
and
you
then
had
7
to
and
or
then
not.
2x minus 1.
Okay.
That'd be the same thing.
Alright, just in case
Okay.
I forgot to
No,
do
it's
it, I
fine.
didn't know if it mattered.
Just like in your books, they usually put the constant like
Okay.
out in front, just to make it easier. Like this looks visually, I think, a little bit nicer than
Yeah.
this.
Yeah.
You know.
Okay.
So they're all the same if you did it with multiplication. A lot of this is just like subbing things like in more than anything. Let's see if I have any hard ones, and then I think the first one was the worst one. Oh yeah, here we go. Here's the big tough part. We have. Oh yeah. All right. Oh geez.
Yep, how mine could be.
All right.
It's alright.
What do you guys think we're gonna have to use here? Okay, keep in mind we're doing derivatives.
Product rule.
Product rule correction. We might need a correction somewhere for it, but we should be using the product rule.
Correction rule.
Sorry, we probably need a correction somewhere. That's a safety plan.
Sorry, Noel.
So we need to use product rule here, right? Okay, so if you guys do your u prime, which is 1, right, we times it by b, plus x. Now when you guys do your b prime, this is where like our new rules kind of come in, right? We have to take b prime, we have to figure out what this part, the derivative separately is going to be. So what would you guys want to let your a be here? 6, good, what about you? Perfect. How about your du? That's -2. Awesome. You want to do -2? Yes. Great. Okay. So now when we take the derivative of just this part, right, we have to use our little formula. Is the ln of, we're going to times this by the ln of 6 times 6 to the u, which is -2x, times -2. You can leave it out, that's fine. What you'll see though as the final answer, you want to distribute out something that's like a light term between both things to make it a little bit nicer looking. In here, and Kelly, this is kind of like what you were like talking about. And Carolyn, actually, what you were going through too. What operation is going on between all of these? Multiplication. So you don't really, let's say, distribute it by like one thing. Right. If you guys want to like rewrite this just to make it look nicer, x times -2 would be like -2x, ln 6 to the -2x. You know what I mean? Just to make it look cleaner.
You take out
Yeah, to the -2x. Yeah, actually, we just use the minus over here. Yeah. That's what minus. Yeah, and then your book does a lot of this taking out a GCF between both of those. So they leave it as like 6 to the -2x. Then 1 minus 2x ln 6. Kind of like that, just so it looks like a little bit cleaner. Yeah, I think that's it.
Someone doesn't
No, no, you guys got homework. Sorry. That won't be that bad. Make sure you guys have your notes or the sheet though.
I'm not going to be in your class tomorrow. I have to go get pulmonary tests done.
That's why you're playing. That's why you're playing bridge.
You don't need to record it when I see the notes. I'll finish them.
Well, I learned how to